Okay, so let's continue with next subtopic. So today what we are going to do, today we will write the electronic configuration for the first 30 atoms. Right, so let's continue. So first is hydrogen, atomic number 1. So it will be 1s1. And how to write? We can make a box. We'll put one electron here in the orbital. Next is helium. 2 electrons are there, so we'll write 1s2, and we will fill 2 electrons in this. Right? Lithium. This is 1s2, 2s1. So we'll put 2 electrons here and 1 electron here. Then next is beryllium. Atomic number is 4. So as you know, there are 4 electrons. That means it will go in 1s2 and then 2s2. And you can fill the electron like this in orbital. Next is boron. Boron is 5. 1s2, 2s2, 2p1. So it's like this. Sorry. So in the p there are 3 orbitals, subshells. So 1 electron will go here. Next is carbon. 1s2, 2p2. So we'll put 2 electron in 1s2, 2 electron is 1s2, 1 electron here, 1 electron here, right? Next. After carbon we have nitrogen. Nitrogen is 7, oxygen is 8, fluorine is 9, neon is 10, sodium is 11, right? So we'll write 1 as 2, 2 as 2, 2p3. So 3 plus 2, 5, 5 plus 2, 7. So 7. So we can fill the electrons like this. Then oxygen, 1 is 2, 2 is 2, 2p4, right? Next is fluorine, 1 is 2, 2 is 2, 2p5, One, 2, 3, 4, 5. Neon is 1 is 2, 2 is 2, 2p6, 1, 2, 3, 4, 6. Sodium is 1s2, 2s2, 2p6, 3s1, 1, 2, 3, 4, 5, 6. Okay. Then we have magnesium, aluminum, then we have silicon, phosphorus, sulfur, chlorine. So it's 1s2, 2s2, 2p6, 3s2. We'll fill the orbitals like this. There are 2 electrons. Here also 2. In P we have 6. So it's 1, 2, 3, 4, 5, 6. Like this. Then we have 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so 2 electron in this cell, 2 electron in this cell. 2 will already go because there are total 6. Here we have 1. Right? Silicon is 1s2, 2s2, 2p6, 3s2, 3p2. The rest will be as it is. So you can fill in the N2. Right? This will be as it is. Phosphorus 1s2, 2s2, 2p6, 3s2, 3p3. So here it will go like this. 1, 2, and 3. Right? The rest will be as it is. Sulfur is 16, 1s2, 2s2, 2p6, 3s2, 3p4. So it's 1, 2, 3, 4 electron like this. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Here we will do the same thing. 1, 2, 3, 4, 5. Right? We'll go to the next. After chlorine, we have argon. It's 18. Then we have potassium 19, calcium 20, scandium 21, titanium 22, vanadium 23. So this is 1s2, 2s2, 2p6, 3s2, 3p6. So you can check 6 plus 2, 8, 8 plus 6, 14, 14 plus 4, 18. So this is how you will find that the last cell is completely filled. 1, 2, 3, 4, 5, 6. Right? Let's go with the next. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So as these all are filled, right? Here also calcium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So here you have 2 electrons. Now, in case of scandium, you have 21, right? So it starts with 1s1, sorry, 1s2, 2s2, 2p6, 3s2, 3p6, then 3d1, 4s2. Now in 3d1, still the third shell have, if you'll see, if the shell number is 3, how many electron it will be? With this formula, 18 electrons, right? So we can see still third shell have chance to add more electrons, right? So we will add here. In titanium, 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, and 4s2 will be as it is. So if you remember, I'm just drawing the d orbital. D have 1, 2, 3, 4, 5. So 1. 3d2 means 1, 2, 3, and 1 and 2. 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2, right? So here you will find that the d orbital have 3 electrons. One, 2, 3, and 4s2 will be as it is. Now we have chromium, magnesium, iron, cobalt, then nickel, copper, and zinc. Let's see the next. This is important. So this is 1s2, 2s2, 2p6, 3s2, 3p6. This will be 3d5 and this will be 4s1. So why 5? Because if I am going to fill, let's say, electrons like this, let's say if I'm going to put 1, 2, 3, 4, 5. Earlier, if I'm going to put 4, then what you will find that the last cell have 2, this one have 2, and there's always a concept of um, half filled. So most stable is fully filled orbital, more stable than half filled and empty. So to give one electron, make everything as a half filled. Half filled are more stable than empty. That's why this has happened. In magnesium, 1s2, 2s2, 2p6, 3s2, 3p6. Now here in 25, 3d5 will be there as it is. Then you write 4s2. Iron, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Right? In case of nickel, 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, then 4s1. Now if I'm going to put 9, what difference you will find is, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be empty, half filled. So we know that there is already 2 electrons, so one will jump from here to make this particular orbital stable. But in the next, what we will do, we will just add to 4s2, 4s electron. Like this. So most important is atomic number 24 and 29. IB asks questions from here. Thank you and see you in the next video.